Lesson 32 is about slopes of linear graphs or equations in the slope-intercept form. This is the equation we started with in the last lesson, and we're going to continue with it this time. Call any time that you have two variables in an equation, two linear variables, that is, there are no exponents, then you can graph it. Actually graph a three-variable equation. However, that becomes quite cumbersome in a three-dimensional graph, and we won't do that in this lesson. In this two-variable equation, we will solve in terms of x. We will solve for y in terms of x, just like we did last time. Now, this time I'm going to rearrange and put the x term in front. This is a very important format of an equation in that this is called the slope-intercept form. To stay consistent with the previous functions lesson, I will rewrite this with the function of x. So when your equation is in the slope-intercept form, this value here is the slope of the line, and this is the y-axis intersection or intercept. In this lesson, we're just going to talk about the slope. The slope is -2. What do we mean when we say slope is equal to the rise over the run? Well, basically, that is the same as how much does it change vertically in relation to how much it changes horizontally. The rise could either be positive or negative. It's positive if the graph is going in an upwards direction, and it's negative if the graph is going in a downwards direction. Run is always to the right. We never look at run to the left. Run is always positive. In our case, with a slope of -2, with a negative, that means it changes vertically 2 placements for every 1 placement horizontally. So it's a 2-to-1 ratio. The line changes 2 placements vertically for every 1 placement horizontally, and we know it changes in the down direction. So the slope is in that fashion. It's not to say that this line goes to this point of 0, 2 and 1, 0. It's just I just drew these increments here to show the relationship of the 2-to-1 ratio. Let's go ahead and graph this equation, this function, just to go ahead and see what I'm talking about here. And I'm going to go ahead and put one more point just to help me draw the line. Okay, I'm not going to draw the line because it will cloud up the graph too much to make my point here. My point here is we're looking at the slope. The slope is -2. That means it's changing 2 vertical clicks for every horizontal click. And let's just check that. So here we have a point and y is 6. So this is a value of 6 difference. And here it moves over 3 horizontal, and that's 3 clicks. So we have, and it's going down, so we know it's a negative. So our rise over run equals a -6 over a 3, and we've just extracted this from the graph. Factoring that out, we see that that is indeed -2, which matches the slope of the original function. And we knew the slope of the original function because this was in slope-intercept form. Clearing the slate, and just to recap on our original equation, that results in a negative slope. If we had this function, that is a positive slope, because this value is positive. So what do we have to have if we want a horizontal slope? Well, horizontal slope means there's 0 rise over a given number of runs or clicks or horizontal increments. That means slope would be 0. So if slope is 0 and we plug it into our slope-intercept form, that goes to 0, and effectively f of x equals 6. And that's the resulting graph. And I've just cleaned up and rearranged. Now, what if we have a vertical line in our graph? If it's truly a vertical line, it will never intersect the y-axis or the f of x axis. The problem with this is slope is rise over run, but look at our run. Our run is 0. Run equals 0, and that means we have a 0 in the denominator, and that is not possible. So a vertical line has an undefined slope. Whereas we had a 0 slope up here for horizontal line, a vertical line is an undefined slope. In closing on this lesson, I'll just point this out one more time. So it is possible to draw your graph just using these two known concepts. Say we have, we'll do a function of x. Without even doing a table of x and y values, I know that the line will intersect here, and I know that there's a rise over run of a 2-to-1 ratio. So for 4 rises, there's 2 horizontals, and we could draw it that way. Just all you need for a straight line, you know it's a straight line because it's a linear equation. All you need to draw a straight line is 2 points.